Hello, my name is Brett Formosa, and welcome to Unity tutorial video series for beginners. For this series, I'll go through each step with the mindset that all you've done is install Unity with no prior research or experience to make sure everyone can feel included and learn as we go. You can contact me either through the comment section down below, by visiting my personal website, or by leaving a message on my itch.io page. The links are in the description of this video. Last video, we made the player game object respawn when hitting an asteroid and when hitting the top of the goal screen. However, I ended the video with the game not working properly while prompting you to see if you could fix the issue. I also prompted another challenge on trying to get the asteroids to not respawn when hitting a player game object, but respawn when they hit the colliders on the sides of the screen. In this video, I will go over my solutions for the two challenges, as well as getting a working scoring system in place. Let's get started with part 6. I am going to preface that any challenge in the last video, or even future videos, can be done numerous different ways. So, by all means, my way may not be the most efficient way, but it will be a simple way to get the challenge done, while also being as efficient as I personally know how to. There are thousands of ways you can write code to do the exact same task. It all depends on personal preference and ability. For the first challenge of getting the player game object to work properly when hitting either the asteroids or the top of the screen is by adding a capsule collider 2D to the player game object. If we do this and hit play, you can see colliding with an asteroid will get the player game object to teleport to the collide spawner, and if you make it to the top of the screen, you see the player wrap around from the top of the screen to the bottom when they hit the top collider. For the second challenge, it was a little more complicated, but all you need to do is add a collider tag to the left and right collider by clicking on them, then click the drop down for tag and clicking new tag. Then click the plus and add a new tag such as collider. Then make both the left and right colliders tagged as collider. That is the first half of the solution. The next half, we needed to add some code to the Asteroid Manager script. So let's open that. We just need to add a simple if statement saying if collision.gameObject.tag equals, and then in quotations, collider or whatever tag you wrote before. Then keeping the transform.position line and putting it in the new if statement curly brackets. Let's save this and hit play, and we should see that the asteroids continue moving through the player game object while also going back to the other side of the screen when they hit their respective left or right collider. With these challenges done, let's get to more learning. If you completed one or both, then good job. It means you are learning. If you haven't completed them or got stuck, hopefully just a little more practice and you're all set. Either way, good job for trying. We want to finally create some UI elements such as a timer and a scoring system so the player can see how much time is left, while also seeing how many times they've reached the top of the screen. Right-click in the hierarchy and go to UI, Text, Text Mesh Pro. A pop-up may come up. If it does, click on Import TMP Essentials, and then after a few seconds, you can close the pop-up and you'll notice text and then TMP in parentheses in a canvas game object. Click on canvas, then push F to focus it in the scene window. You'll notice the canvas is much larger than where the game is being played. This is completely normal as the canvas is set to whatever resolution you want it to be, and by default, it is to the size of your screen, but converted to Unity units. So if you're using a 1920 by 1080 monitor, the canvas will be 1920 units wide and 1080 units tall. It takes a little bit to get used to, but it is entirely normal. We need to see the game view and the scene view, however, to make sure we are adding things in the right spot. So let's move the game view to the bottom right corner for now. On the canvas scaler, if we click UI scale modes drop down, we can change it from constant pixel size to scale with screen size. Then, add the reference resolution to whatever you want it to be. Usually, it's the scale of the device you're planning on exporting the game to. So, in this case, let's just do 1920 by 1080 or whatever your resolution is for your computer. What this does is no matter what size the game view is, the UI scales to the 1920 by 1080 screen size. If we were to keep it on the constant pixel size, the UI in game would change drastically. Let's click on the text TMP game object and anchor it to the top right of the screen. We do this by clicking on the box in the rect transform. Then, while holding Alt and left shift, we will click on the top right box. This will anchor the text to that portion of the screen. What anchoring does is if someone played on a lower resolution monitor or even a different aspect ratio monitor, the UI will always adjust from the top right corner instead of the middle of the screen, for example. In the Text Mesh Pro text UI component, we will change it from saying new text to just 0. Let's also click auto size with min being 18 and max being whatever you want it to be. Let's put the number to be aligned to the right side of the text box as well. Then, let's scale and move the text box to a suitable size and position. Unlike other components for game objects, I won't be going over the components for the canvas and the Text Mesh Pro game objects due to them being either self-explanatory or too advanced for now. Text Mesh Pro's components are very similar to any word editing software, which is another reason why I'm not going over each individual spot. However, as always, if you want me to go over everything in more detail or anything in more detail, let me know down below. Let's name the new Text Mesh Pro's score. All we need to do now is add a script to the score number so that when the player reaches the top of the screen, then they get placed at the bottom and the score increases by 1. Now, we're going to call a script from another script, something we haven't done before. Technically, we have with Unity's built-in scripts, such as onCollision Enter 2D, but we will make a customized one and I'll walk you through the steps. Let's add a script to the score Text Mesh Pro and let's call it Score Manager. Let's open that script up. We do need a few variables, so let's just write what we need. This script will keep track of the player's current score and will increase until it hits the maximum score value. With this knowledge in mind, we just need a private int current score and a public int max score variable. Now, for the portion of the script that needs to change game objects, we just need to update the UI score game object to keep the current score on screen at all times. We need to manipulate the Text Mesh Pro UI, which needs a new library. Let's go to the top and type using TM Pro. Next, we just need to add the variable, which will be public TMP underscore text score text. We can now remove the update function, and in the start function, we want to make sure everything is zeroed out. To make sure this happens, we will simply write current score equals 0 and score text dot text equals current score dot toString parentheses. The score text is just using the Text Mesh Pro game object, and since we want to manipulate the text, we need to write .text to specify that is what we want to change. Text Mesh Pro's text only uses strings, so we need to convert the current score's integer value into a string, and to simply do this, we just write .toString, with the parentheses, and it will use Unity's built-in int to string script to convert the integer to the required string. We will now write a new function, public void increase score parentheses, and then in the curly brackets, we will write the following, current score plus plus, and we will write the same as in the start function, score text dot text equals current score dot toString. The plus plus after the current score is a shorthand way of saying current score equals current score plus 1, which simply takes the current score and adds 1 to it. If it were 0, it would now be 1. We can also do this with subtraction. If we wanted to take a point away from the player, we could write current score minus minus, which is the shorthand way of saying current score equals current score minus 1, which does the opposite of current score plus plus. We can save this and then open up the player respawn script. In this script, we just need to call the increase score function from the score manager script to increase the score when the player hits the goal collider. We just need to add in one line, and it is game object dot find game object with tag. In parentheses and quotations, we will write score dot get component, and then in arrow brackets, we're going to write score manager parentheses dot increase score parentheses. This may seem daunting at first, but ultimately what this means is this script will look through all of the game objects in the hierarchy and find a game object with the tag score. Once it finds that game object, it will grab the score manager script and then call the increase score function. One thing to make note as well is while I try to teach the most optimized way that I personally know, this is actually quite unoptimized, as if you have a game with hundreds or even thousands of game objects, the GameObject.find function goes through each of the game objects. While this current project doesn't have too many game objects, you don't notice it while playing the game. However, lag issues may arise depending on the size of the game. I will go over more optimized approaches later on in a future video series. However, one thing to note if you want to research yourself is to get started learning singletons or putting in code to grab a game object and store it in a variable, unlike how we did it with the current score script. Let's save the script and go back into the Unity editor. We need to give the score TextMesh Pro game object the score tag, which we need to create. Let's create that the same way we created the asteroid, goal, and collider tags. Next, we need to drag the score TextMesh Pro game object into the score text box for the score manager script, so the script knows what game object it will be changing. Now, if we hit play, we can test out the score going up whenever the player game object hits the top of the screen. The max score we will touch on in a future episode when we touch on a menu system, so we can leave that as 0 for now. However, even if we leave it at a number, the score will still increase past that amount since we haven't told the script to stop at the max score and do something in particular. This, however, is where I'll end the tutorial since we did what we needed to do in the episode. So let's take a break and you can meet me in the next episode where we will go over how to create a timer for the game. Take care, and I'll see you in the next video.